Hello friends, welcome to AI Flux. So today I want to go over one of OpenAI's more recent releases, which is a tool called Point E. Basically, this is an AI that improves on prior work by Google and a few other companies when it comes to generating point clouds based on text inputs. And another really interesting thing that OpenAI has added to this recently, or that they've talked more about, is that you can actually feed images in and then generate contextually based meshes from those images. So again, it's a prototype, so it's not intended to be perfect. Some of Google's work with direct to 3D or direct to NeRF projects, they went for a perfectly contiguous mesh. And what I think is interesting with Point E is that they said, well, let's shoot for a more bead-like mesh or a mesh that has lower fidelity and work on the accuracy of the model actually creating things that we want it to. So there are a few examples here. You can see a corgi wearing a red Santa hat. The pumpkin one is cool because there's less mirroring going on, and a lot of other models kind of cheat when the demo is only shown with very dimensional or squared objects. So you'll see chairs or cars, and basically it's something that you can mesh half of and then revolve and then have one thing there. What's really impressive or telling about these models is when you look at, like, clearly there's still an opening between the legs, and then with the glasses, there are two sides, and in the chair, see the back leg is actually connected and there are four legs, which is kind of cool. So what makes this actually interesting is that a lot of these companies, especially OpenAI with their recent potential influx of cash from Microsoft, they're working harder than other companies to find real applications for this. So the people who want to use this architecturally, or 3D artists who want to speed up their workflows, that's really the angle of what these will be used to do. And the other curious thing with Point E that is different from a lot of OpenAI's prior releases is that it's intended to be lighter weight. And I think this is a trend we're going to start to see with a lot of OpenAI's work with Microsoft in terms of how it'll be packaged to run locally. So for instance, right now it says OpenAI open source Point E, which is also kind of a new thing for OpenAI, a machine learning system that creates 3D objects given a text prompt. According to the paper, which is linked in the description below, it's intended to create 3D models in 1 to 2 minutes on a single V100 GPU. So something that an artist could have in their machine locally, negating the need for a lot of very expensive tooling that right now for a lot of these AI businesses is their biggest line item when it comes to expenses. So it's a really interesting thing. One, that they've decided to open source it. Two, that they've hinted, not directly, but there are a lot of attributes here that point to this technology being intended to run local and not be a cloud offering, which is pretty interesting. And also image inputs along with text inputs, although in a lot of ways, these models can be used in both ways pretty easily. See what else they say here. An important thing to note, given what I just said, is the E in Point E is short for efficiency. The idea is get this going as fast as possible and build it so you don't have to have a supercomputer to really use it. And another important thing to note here is that this is not generating a point cloud that is necessarily a NeRF right out of the system. Point E generally stands for point clouds, and a lot of the efficiency gains here are gained by the fact that they're using a point cloud. And as you can see here, they say point clouds are easier to synthesize from a computational standpoint because they don't capture an object's fine-grained shape or texture, and not needing a texture is key. NeRFs do require a texture, and they add a lot of complexity for that reason. So what's interesting is they go into a little bit of detail, and OpenAI is just expunged. So what's cool is OpenAI has actually shared a fair bit of detail as to how they've managed to get some of these speed ups. And of course, if you read through the code, you'd probably be able to figure this out, but not many people can really dig through it and get everything out that they could. So they pretty much say here that to get around this limitation, the Point E team trained an additional AI system to convert Point E's point clouds to meshes. Meshes being a collection of vertices, edges, and faces that define an actual object and are used in 3D modeling tools like Blender, C4D, etc. But they note in the paper that the model can sometimes miss certain parts of objects, resulting in blocky, distorted shapes. And what's cool is this, it might seem like a negative, but it shows that the model isn't cheating by just mirroring a half pass and then merging that. which I think is kind of cool. The other cool thing is they pretty much go into here how they've just reused the text to image model and have another way to output from it. So pretty much given a text prompt, for example, a 3D printable gear, Point-E's text to image model generates a synthetic rendered object that's fed to the image to 3D model, which then generates a point cloud. So that's kind of what's going on behind the scenes here. They also trained it with actual 3D objects, which is kind of interesting. There are a lot of others that rely on using sort of a photogrammetry approach with images and not 3D shapes, which I think is a cool, novel approach. And it's also cool that they've actually said something about it. So this is an example of feeding images in and getting meshes out. Notice that there's a bit of an attempt to color match, but that's not necessarily a texture. That's a point match of color, which is pretty cool. There's some notes here as to why they think this is kind of a novel thing. So they say here, while our model performs worse on this evaluation than state-of-the-art techniques, it produces samples in a small fraction of the time. This could make it more practical for certain applications or could allow for discovery of a higher quality 3D object, which points to some other things we've seen in a lot of the photogrammetry approaches, which is kind of a convolutional approach where you create a bunch of versions and then you compare those against a ground truth, and by that either improve the shape you've gotten or pick the best ones and then use those to make a shape. And then they show some other things that have gone wrong, which is interesting. As always, I think it's way more interesting to see failure classes in these models than where they work perfectly, because then you see what the real bounds of their capabilities are, which I like. And as a software engineer, I think that speaks to the quality and the breadth of whatever you're working on way more than just what it can do perfectly. So pretty cool. The paper's linked below. I think it's worth a read if you're a software engineer or someone who wants to learn a bit more about some of the approaches here. What's really cool is the paper and the code is all available. So if you want to dig in, you have everything there to extrapolate and see really how this stuff works, which is not common. Also, there's a reduced fidelity demo on Hugging Face. Really important to note that this is not the one they reference in the paper. It's a trimmed down model so it can run in a reasonable amount of time. I've made a cone with this and it worked pretty well. I'll show you in just a bit what that looks like. The shape that was on here before was a palm tree. And what I found is it gets shapes pretty well right, but the color matching is not as good. And you can see here, this is, oh wow. So clearly it matched the colors of an explosion to a mushroom, which is kind of cool. It's actually better than I expected. Looking at it like this was not, I was worried there. Now I'll do traffic cone just to prove a point. And what's also really cool about this is I didn't realize that Hugging Face had new integrations for nerfs and live viewing meshes, which is kind of cool. It's always cool to see how Hugging Face is improving and making these interactive demos better. All right, so this is actually not as good a cone as I had before, but as you can see, it's orange and roughly resembles a cone. But anyways, I'll link this in the description below. This is a shorter video, but I want to make a few more of these updates. But as always, I hope you learned something, and I'll talk to you all soon.